Of the students in Molly's homeroom, 11 students have brown hair. 7 have black hair. 5 have auburn hair. 4 have blonde hair. 3 have red hair. Probabilities. Calculate the relative frequency and round the answer to the nearest thousandth. So relative frequency is a percentage. The probability of having black hair is going to be 7 out of, wait, what's the total? There are 7 students with black hair, so that's why I put a 7 on the top, but I need to know the total out of the bottom. Hey Siri, what's 11 plus 7 plus 5 plus 4 plus 3? Great job. Hey Siri, what's 11 plus 7 plus 5 plus 4 plus 3?
It's 30.
Okay. There's my total. Auburn hair, A, or red hair, B. You can't have both, in this scenario. Maybe there's, things that you can do, but that hasn't been outlined in the parameters of this word problem. So we might want to be able to be aware of probability of auburn plus the probability of red hair. Take away the probability of both auburn and red hair. We're just adding the probability separately. Probability of auburn hair, 5 out of 30. Plus the probability of having red hair, 3 out of 30, which is 8 out of 30. This is independent. So 8 out of 30, we need that percentage. 26.7%, by the way. 7 out of 30 is 23.3%. Now, this not brown hair, we're going to say not, and then I'm going to use a little like exponential C. See, there we go. Exponential C as our probability notation for not. But it means everyone else. 100% of the students have, in this situation, have hair of various colors. Take away the probability that have brown hair, so minus 11/30ths, and you get the probability of not brown hair. So we need to know 11/30ths. And we're going to make that negative, and we're going to add 100 to it. Whoa. 11/30ths, there we go, times 100. Make that negative, and add 100 to it. 63.3% of the students do not have brown hair. Last of all, probability of brown and black hair, that's an intersection. So the probability of brown and black hair, they're independent. It's 0 out of 30, aka 0%. Right, where there's no overlap. There's no like two-way. It's just one category. In order to do a two-way table, we need 2 categories that have the opportunity to overlap. And if we don't see those, then whenever there's an intersection question, the probability is 0. Last one, page 842. Here we go. 4 questions right now. A two-way frequency table shows the number of students from each grade who plan to attend this year's homecoming football game. So we have frequency table and turn it into relative frequency by dividing everything by 174. That's what question 2 is saying. Did you think creating a relative frequency table is more efficient than calculating each probability separately? Did you use an intersection or union to determine each probability? The word and means intersection. A freshman going to the homecoming game. So a freshman, 48 out of 174. Going to the homecoming game, 116 out of 174. So 48. Oh, the interaction, sorry. What am I doing here? This is, so interaction, you should be able to multiply. You should be able to multiply them. Yeah. Let's check this. I know that it's going to be 31 out of 174. So I'm going to put a big old question mark on this and be like, is that true? I know that's the right answer, though. 17.8%, because this is the freshman that's attending homecoming. A sophomore not going to the homecoming game. So a sophomore not attending, 24 out of 174, which is approximately 13.8%. What about students from all grades going to the homecoming game? So freshmen, sophomores, juniors, seniors, and going to the homecoming game, that's 116. Because that's all of these students who are going out of 174 who are not, which is 66.7%. What if they're not a junior and they're not attending homecoming? So not a junior would be, well, in the not attending, it'd be this one, and this one. So 17 plus 24 plus 6 out of 174, which is 47 out of 174, which has an answer of 27.0%. Thank you for watching, commenting, liking, and subscribing. This has been the Talk the Talk activity from Lesson 1. Lesson 1 is done. Two-way contingency tables. In the next lesson, Lesson 2, we're going to talk about conditional probability and how things depend on one another. And this table idea is really solid for helping make that be a balance. Stick around, watch those videos. I'll see you in the next episode, Lesson 2. Thank you for watching all of these. Have a good one.